In today's video, we're going to be looking at volume. So we'll look at prisms and cylinders and do 3 examples. Then we'll look at pyramids, cones, and spheres and do 3 examples there. So first, here are the actual formulas. A prism and a cylinder have the same formula. It's just the area of the base times the height. Capital B matters. Capital B means the area of the base, not just a base. And then the volume of a cone or pyramid is almost the same. It's just 1/3 times the area of the base times the height. Okay? And then the last one here is a sphere, which is going to be 4/3 pi r cubed. A way to remember cubed is to think about the fact that volume is a 3-dimensional measure, right? So we need to be cubed. And we'll see that in our units too. Okay, focusing on prisms and cylinders, here are some steps you can kind of think through when you're doing these problems. Find the volume of the prism, round to the 10th if necessary. So here we have a triangular prism. The first thing I always like to do is identify the base, and an easy way to do that is to shade the base. Your bases are always going to be parallel to each other, okay, when you're looking at prisms and cylinders. So here we have triangles and we have 3 rectangles, right? But none of the rectangles are parallel to each other, so they can't be the base. The triangle has to be the base because the 2 triangles are parallel. So I just like to shade. It just gives a good visual. Okay, so we need to first find the area of the base because our volume formula is area of the base times the height. Right? So we need to find B, capital B. How do I find the area of a triangle? Yeah, 1/2 base times height. Now here we're talking about lowercase b. There's lots of bases and heights here, so we got to be careful. Right here we're talking about the base and height of our triangle, not the whole figure. So our base and height are always at right angles, and we can see that this right angle is here, which means it's also over here. So if your base and height are not at a right angle, then they're not your base or height, okay? So 3 and 4 is our base and our height. So that would be 1/2 times 3 times 4, okay? Half of 4 is 2 times 3 is 6. All right, now the last thing is I just need to multiply by the height. We found B, so B equals our B, which was 6, times the height, and this time we're not talking about the height of the triangle, we're talking about the height of the prism, which is the distance between your 2 bases. So we're talking about this length here, which is 7, and 6 times 7 gives us 42. We did meters times meters times meters, so that is meters cubed. And there we go, that's it. Okay, let's try another. Here we have a cylinder. I like to follow the same steps. So shade the base. I know the base is the circle because the circles are parallel. So the first thing I need to do is identify the volume formula, which would be area of the base times the height for a cylinder. The area of the base, what formula do I need to find the area of a circle? Okay, it is going to be pi r squared. R is given already. Remember, radius is only half the circle, not the full width of the circle. So our radius is 1, so that's going to be pi times 1 squared. Well, 1 squared is just 1, and 1 times pi is just pi. Okay, so that's my big B. Now I need to multiply by my height, and we're talking about the height of the cylinder. And we find that by finding the length between the 2 bases. So here are my 2 bases, and that length between is 6. So this one doesn't have much left to do. It's asked us to leave it in terms of pi, which means we're not going to evaluate the final answer. We're going to leave it with pi there. It gives you a more exact answer. Whoops. I don't know why it's doing that. Okay. So it's just 6 times pi, which is 6 pi. Okay. If we wanted to actually use this volume, we would then type 6 pi in the calculator and get a final answer there. But we're not worried about it for right now. We're just practicing the formula, and that would be centimeters cubed. Okay. So we're moving on. Let's look at volume in a context. Okay. A moving company is trying to store boxes in a storage room with a length of 5 meters, width of 3, and height of 2. How many boxes can fit in this space if each box is 10 centimeters by 6 centimeters by 4? So we've got one big storage unit, which is a rectangular prism, and then we're trying to fit all these small boxes inside it. So there's lots of different ways you could approach this problem, okay? I like to sketch a picture. It doesn't have to be exact. I like to think of this as a volume problem, but you can go at it from lots of different ways. Now, something we need to pay attention to is that we have two different units being used. So this is centimeters and this is meters. We need to make a match. I don't want to deal with decimals, so I'm going to make my meters into centimeters. So there's 100 centimeters in a meter, so that just means this is 500, 300, and 200. So now I just need to know how many of these fit into this. What do you think? Okay, so let's go through it. I'm going to find the volume of this, which is going to be 500 times 300 times 200. So 500 times 300 gives me the area of the base, then times 200. You could also think length times width times height, right? And that's going to give me 5 times 3 is 15, times 2 is 30. So this is going to be a big number. We got 30 plus 2, 4, 6 zeros, so 30 million. So this is 30 million cubic centimeters. And this one is 10 times 6 times 4. So 6 times 4 is 24. 24 times 10 is 240. So 240 cubic centimeters. And if I want to know how many of these fit into this, I just divide. So I'm going to do 30 million, 1, 2, 3, 1, 2, 3, divided by 240, and that gives me 125,000 boxes. Okay? All right, so we are moving on to cones, pyramids, and spheres. So pretty much the same process here. Identify the base. The base is a little easier to find here because it's the one opposite of the point. So in this case, we have a square. But the formula is 1/3 times the area of the base times the height. So we still need to find the area of the base. How do you find the area of a square? Good, length times width. So length times width, or base times height, you could say that. And that's just going to be 5 times 5, which is 25. Okay, and then I need to do 1/3 times the area of the base, which was 25, times the height. Now, be very careful here. The height, it's not the slant height. The slant height is used for surface area. We don't want that. We want the height of the pyramid, okay? And remember, I talked about being perpendicular, making that right angle. So look for that right angle here. So the height is 3. Okay. Well, 1/3 and 3 cancel, so we're left with just 25 inches cubed. All right, moving on. Let's try a sphere. And spheres are pretty straightforward as long as you remember the formula. So what is the formula for a sphere to find the volume? 4/3 pi r cubed. Very good. So I need to find r and just plug it in and evaluate. I do want to leave in terms of pi, okay, so be careful of that. Right now we're given our diameter, okay? The radius is only half the length. So my diameter is 10, the radius is 5. Be very careful. They like to throw that into problems to throw you off. So 5 cubed. So in my calculator, I'm going to do 5 cubed, which gives you 125. Oops, sorry, I put a 5 down here. That should be a 3. So now I have 4/3 times pi times 125. I don't want to round it all, so what I'm going to do is I'm going to multiply 4 times 125. It is not divisible by 3, so I'm going to leave it as a fraction. So if I do 4 times 125, I get 500 divided by 3, and then I have my pi. So now I have an exact value that didn't have to be rounded at all. Whenever I'm ready to use it in the real world, I can just plug it into a calculator and get the decimal. But right now, it's exact. Kilometers cubed. Okay? All right, and our last problem here is another volume in context. So the height of a cone is equal to 3 times the radius of the base. If the base has an area of 49 pi centimeters squared, what is the volume of the cone? Leave your answer in terms of pi. Oh, interesting. Okay, so let's draw a picture. I have a cone. All right. And it tells me that the height of the cone, right, so it's at a right angle, is equal to 3 times the radius of the base. If the base has an area, so it doesn't tell us the radius of the base, it tells us the area of the base. So it tells me that the area of the base, which would be our capital B, right, is equal to 49 pi. What is the volume of the cone? Take a minute, see if you can figure it out. Okay, so as you're working, you should see that the formula for the volume is 1/3 area of the base times the height. Well, we have the area of the base, what we don't have is the height. We know the height's related to the radius, but we don't have the radius. Lucky for us, we have the area of the base, which involves the radius. We know that the area of a circle is equal to pi r squared, and if 49 pi has to equal pi r squared, I know that r has to equal what? 7. R has to be 7. So I know that h has to be 3 times 7, right, which would be 21. So now I can finish finding the volume. I can come over here. Volume is equal to 1/3. Now the area of the base, they've already found for us, 49 pi. And we now know that our height is 21. 21 divided by 3, so that cancels to be 7. 49 times 7 is 343 pi. Leave your answer in terms of pi. I think we are done. And there you go. There's a few problems on volume.